We have time for questions and answers. So if we take a Q&A, first of all, on Stefan's talk about the glass-to-glass latency, and then we'll take questions on Erik's talk on AOSP building and custom devices. So first of all, then, any questions for Stefan?
Yes, I have a question to Stefan. Thank you, Stefan. It's very interesting topic. For me to confirm that I understood correctly, this like HTML file, so it's dynamic, yeah. So when I open it my browser, I can see almost in real time like what happening on the device.
So yeah, it's a recording of events. And yes, then it's saved up and it's a static file, but it has a bunch of JavaScript code in it. So it shows a GUI, and then you can inspect in that GUI. So you can zoom in, you can select events and so stuff. Yeah.
And how to determine time when I start recording and when I stop recording?
You have the Python script, which is called Systrace, and you start it and give it a time option, so you can control it if it should capture 2 seconds, 4 seconds, or 10 seconds. Or if you leave out the time option, then it just waits for a key for a key press. So it's not a live view on the system; it's a recorded view on the system.
Okay, yeah.
Does it answer the question? Okay.
There's a question from Pratik in the chat.
I'm trying to read it up.
Can you see that, or I can read it out?
I have to maximize this. I think this calculation is based on 33 fps camera source. Right? Yes, it's correct. It's a 33 fps camera. This the sensor to camera will minimum 30 minutes. Kernel as a frame buffer to queue, so I believe the mean latency will be 60 milliseconds. Please confirm. So it's not only about the sensor, and it's a tricky question. So I only believe the number when I've measured it. So I think the kernel does not necessarily do queuing of a whole frame. So it gets the frame from the sensor mostly via DMA. So it's queues the sensor image in the kernel or in the RAM while it's streamed in from the sensor. But if it's ready at this point in time, then it can push that once to the app. Mostly in my capture, it took still 24 milliseconds from the end of the sensor exposure to the app. But it is clearly not fully buffered, so it's not really cute.
But don't you have also to take in consideration the performance of the camera provider, HAL, in this case?
Yes.
What your app sees is not directly the kernel. It goes all over the HAL plus the system service, and then it gets back to your app. So you also have some latency there.
Yeah, and this latency is 25 milliseconds. So I do not exactly know what the HAL is doing and how it's processing the frame, but it's 25 milliseconds in my cases. So it's not a full frame. So, and also what I know, okay, it's the timings. In the Android Camera 2 API, there's also some properties telling how many pipeline steps your HAL implementation have. So maybe your specific HAL implementation will tell you how long it will take, how many steps it has in between. In my cases, it was not a full frame.
Okay, anyone else? Okay. So let's open it out a little bit then. Anybody else, well, first of all, did anybody have any questions for Erik and his presentation on building custom Android devices?
I have a question.
Okay, go ahead. Yes.
I have not tried out Android 14 yet, but it will come up in my project in some months. How flaky is it really? So you told about it's flaky, so
no. So if you use the Zoom stuff, I think it's stable enough. It's the new basal integration that is kind of flaky, and it doesn't seem to be used in most of the stuff. So
what I saw when I was playing with Android 14, but I'm not sure if it's because of the transition to basal. For me, it's taking, let's say it's very subjective, but it's taking much more time to actually start the build when I modified something in an Android BP than what it was doing for 12.1 and 13. And it's basically, I don't have a slow machine, but it's sometimes allocating, this is what I was mentioning in the chat, allocating sometimes 40 gigabyte on one thread and taking something like 30 to 40 seconds before actually it starts building. And
yeah, that's
really for me a drawback in the performance of the build system, because 12.1 and 13 were, let's say, workable. But here it's, you tend after that to restrict yourself modifying too much your Android BP when you're developing.
Yeah, yes. I don't have any good answer here. It's gonna be slow, and I don't think they're gonna have the best performance ever, and doesn't look like they're gonna be less code to build in Android anytime soon. So.
Yeah, I would endorse that. So I think I mentioned that in my experience, Android 14 is more flaky than building Android 13 or 12 or whatever. That may just be my setup. I'm using a fairly old machine now, which only has 32 gigabytes of RAM, and it doesn't have a big swap file. So maybe I'm just running out of memory. That's quite likely. But also, it kind of terminates without an error message. It just says Zoom failed.
But this might be related to what I was mentioning in the chat with this out of memory, this OM daemon. I don't know which Linux distribution you're using, but starting with, I think it was 2204, they introduced this OM daemon. And even if you have enough physical RAM to build it, if your swap is not big enough, because by default, I think Ubuntu uses a 2 gigabyte swap file, even a simple repo sync with lots of threads will be killed. And when it's killed, it's quite tricky, because this is exactly the symptoms that you're telling. You don't see anything on the console, or not that much informative. And you have to go and look in the D message in order to see that the OM daemon has killed some of your processes. And this might be what's happening in your case. So I would suggest that you put, let's say, some 64 gigabyte of swap somewhere and see if it helps. It will go down, but it's gonna help.
Yeah, so the RAM is probably, that's the given thing. You probably need 64. I have 64 on mine. But another thing to test if you run into this problem that the build just fails, reduce the number of threads your build uses. It may sound weird, but it's actually I actually seen better performance sometimes. And as far as I can understand, it's also about how fast your disks are. So if your disks are not super fast, running like, I don't know, 48 threads, if you have 48 cores or whatever, it might not be the best idea. So then just reduce that one. So that's can also be a trick to try out if you notice that your builds are very slow and it just fails.
Yeah, but, so just to clarify, the operating system I'm using is Ubuntu 20.04. I haven't upgraded to 22 yet. Everything worked perfectly with Android 13 and earlier. I just noticed some random build failures with Android 14. I haven't really had a chance to diagnose them. It might well be that my machine's too old and I need to buy a new machine. I've been contemplating doing that for a while, because it's 5 years old. It's an old computer. It was when I got it.
Yeah, so that's also a recommendation to everyone who wants to get started with this. If you're doing this professionally and not just for as a hobby, you can rent really high-end servers, like the Hetzner site, for instance. They have like physical dedicated machines, with like 32 or 48 cores, super fast disks. It costs maybe €100 a month or something like that, but it's time, money well spent if you're working with this professionally.
And if I may stop saying disk, but say SSD, because building the AOSP on a hard drive, you can forget it.
Oh yeah. Don't.
Yeah, that's not been possible for several releases now.
I don't think so. No. I remember when I used to do that.
Yes.
Yeah, if it's interesting for anyone, I made a few benchmark because I'm still playing with different Linux flavors, different Android flavors, different build environment. And actually, the build time difference, if you use a very good old SATA SSD compared to a PCI Express 4 M2 SSD, is not that big. For me, it's around 10% slower on a SATA SSD. But if you compare after that to the easiness of switching the SATA SSD to an M2 and also the price, I would say using a good old SATA SSD is sometimes not a bad idea.
Okay, yeah. Erik, you mentioned a kind of cloud rental service.
Yes.
Could you pop a link to that in the chat?
I'll pop a link to it. It's called Hetzner. That's one of the sites that I'm familiar with. Just have to, yeah, there it is. That's the site.
Great, thanks.
They also sell their old servers. You can buy them and I think, I haven't done it. I rent when I need something super fast. Otherwise, I have a fairly okay desktop thing with 16 cores. That's good enough for me.
Interesting. Good.
Maybe it is, at least for me, Android 14 is like, I found it is great, and it's my daily compiling Android 14. So I don't think there is a big problem compared to the previous versions. There is no such like a big problem. Already I working in virtualization using CrossVM and Cuttlefish based on Android 14, even before the announcement of Google this October 4. So we are building every day Android 14 without any problem. But in my work, the desktop is like have a good performance, like 64 gig and SSD, of course, and 32 cores. But as Erik mentioned, that you need always to reduce the number of threads that you are being like using -G, like 8 or 10 or whatever you want. Even my personal computer in my home, I can compile successfully the Android 14 without any pain.
Yeah.
Okay. So you're saying basically it's my fault. It's down to me.
Yeah. This day. Also,
it's good to know.
Yeah. Also about the presentation of Erik is very interesting. Just I wanted to mention something that about how to inherit or import things is I'm like agree with that, but there is also best practice that we have to do, like having like a common folder that have things like very common for your device, like some device may have Bluetooth and others they don't have, and even you can have like different architecture like ARM64 or x86, for example. Even nowadays we have this RISC-V architecture also. And of course, we if you wanted to pass the certification of Google, we have to respect some rules, like you have your own product brand and your keys, like to generate which we call it fingerprint, and many things that's pre-arranged by Google. So we don't do that like make things just work. So there is some rules.
Yeah, Yeah, when you're doing a Google certified device, you kind of like have a much more restrictions on how things should work, and
Yeah, exactly.
most of the time, the companies who need that, like the most common thing I would say is an Android TV. There are like every carrier or broadband operator wants to have their own Android TV so they can like tie in their customers to these services and just tie you into a device.
Yeah,
That's very
exactly.
common. And these Android TVs, they basically mass produced. It's the same box for everyone. You just put your app onto that one. So in those cases, you don't really have to care much if you're working for the carrier. You don't have to care much about the certification parts. Maybe you're in some of the meetings, but the company who does the base support package here, they make sure everything is working. You just provide some apps to them. That's the most common way, I would say. Then for automotive, it's different.
Yeah, of course. Everything is different to the automotive. Actually, many of restriction and like rules and standards that must be respected. And by the way, linking to Stefan's presentation, the Systrace is a very good tool, and I used it many times in boot time optimization to track the every thread, how much time can take to take up on. And also there is another many tools like Perfetto, as you mentioned also, and there are dump state, and also boot chart is also good tool. And I remember Chris in the first previous, let's say, in this beginning of year, he presented how to use the boot chart. I remember that. And there are many good tools in Android that is very useful for boot time optimization as well. Also for this latency to not just, it's a very interesting setup. I remember when I working with Android TV, my previous company, we are passing the certification of Google, and we have to respect many rules also, but also we have Netflix certification, and Netflix provide a tool that measure this latency and the refresh rate, and basically the hardware tool is like your setup. So great job. Thank you very much.
About the latency, yes, there's a Google compatibility definition document.
Yeah.
And there they also define some latency upper bounds, for example, from touch to display events. So how long it can take. So or for example, audio feedback latency. So when you feed audio in and get audio out, it should be also a upper bound on it. And for these audio latencies, there's also a device you can attach. So there is this latency tests are needed in the wild, yes, and they are mostly I think all similar.
Yeah, and it's very different issue can appear, like the kind of your decoder, for example, when you're using the camera with high quality or that supports hardware decoder like the H264 decoder and hardware encoder, it may be, and it should provide less latency and so on. So many things can interfere.
So here's an interesting fact. You also mentioned Android TV. So this is something that if you work with Android TV, you're probably going to run into this one. You're gonna get a very cheap hardware with very low amount of RAM. When I worked on the last time, we had 2 gigabytes. This means that you probably need to run it Android in 32-bit mode only.
Yes.
And another reason why, this was, I think it was 2 years ago, 3 years ago, another reason why you might have to run in 32-bit only is because you get some DRM framework or library that you need to support, and they only have 32-bit support. That also happens. So like you mentioned the Netflix stuff, and Netflix is fairly okay to work with in this manner because they know how to do this now, but some of the others are less nice to work with and will affect your performance of your device very badly. So that might be things to that everyone is aware of. So if you're working with Android TV custom device and you're having performance problem, don't worry, it's not you.
Well. I worked with like I remember when I basically working in a BSP team of Android. I remember when we are planning to bring up from a setup box that running in Android Oreo 8 to the 11 one. So it's like very hard to make it booting with a good time. So we demanded a waiver from Google to allow us to enable the ZRAM, and we have also some many tricks to add, because this considered like lower RAM devices. So Android TV, like many, is very difficult to handle with this old hardware. But nowadays, I guess we have enough memory.
Well, it's still we're still gonna have to live with this, really.
Yeah, yes.
Like even if Google requires you to have 4 GB RAM, some supplier is gonna provide you with even less than that, and then you have to like tweak it in there to get everything to work. The advantage of the Android TV set-top boxes is that it's usually only one app running at a time, usually. So at least in foreground, so you don't switch between many apps frequently. So that kind of like gives you room to optimize for that app. So there are tricks there. But overall, I would say that those of you who get to work on custom Android devices, like if it's automotive, it's Android TV. If it's something else like a point of sale system or something, it's good to have a knowledge about all of these parts. Even if you're not going to be defining the product yourself, you're just going to write a system app. So it's really good to familiar yourself with everything. And I didn't mention that in my presentation, but my main tip is to get a Pixel device and build there and flash that device and work on that one, so that you have a device that is stable to work on, and flashing it and modifying stuff on it. So that's another pro tip for everyone working with this in daily.
Yeah, it's true. Yeah.
And the pro point for Pixel 3 device that you can get a vanilla AOSP, so you know how how Android should be defined by Google, and then you compare it to your BSP Windows Android fork. Yeah. Good
There
recommendation. Choose Pixel.
Exactly. Yeah. Use a Pixel, and then you can get the official open source from Google, and you don't have to bother about the weirdness that some of these SoC vendors put on AOSP. Extra scripts and stuff.
Yes.
Okay. Anyone else? If not, then I'm going to suggest that we bring this meeting to a close. And I just want to say once more, thank you very much to Erik and to Stefan for 2 excellent talks. And I will publish the videos hopefully tomorrow, and I'll update the AOSP website, and I will send emails out to everyone, or notifications out to everyone, to let you know that's all been done. Meanwhile, I think it's time to call it a day, or at least here in the European arm of things, and hope to see you all at the January meetup, 24th of January, remember. And if anybody wants to meet up in FOSDEM in Brussels a week later, that'd be really great. Meanwhile, thank you very much, and goodbye.
Thanks for the meetup, Chris. Bye.
Thank you so much.
Thank you. Bye.
Thanks. Bye, everyone.